Students, we are continuing the derivation. Torque required to lift the load on the square threaded screw. So we'll start with the derivation now. Now that the free body diagram of this particular system is clear, so we'll start with the derivation. So whatever now we'll do, so only it is based on this free body diagram. So now we are very much aware of this, all the symbols and all type of forces. So we'll start. First step, what we are deriving? Torque required to lift the load on the square threaded screw. Considering equilibrium of horizontal forces. So look at here, horizontal forces. One horizontal force is this effort P, and these other forces also we have to convert into horizontal force. So see how I will write. Left hand forces is equal to right hand force. So horizontal forces we are supposed to write. So see, so P is equal to FRN cos alpha, which is in this direction. Small f Rn cos alpha plus this Rn sin alpha, which is in this direction, plus Rn sin alpha. So let us write it as equation number 1. P is equal to, once again I will tell, F Rn cos alpha plus Rn sin alpha. Now considering equilibrium of vertical forces. So vertical forces F or W. Okay. So either you use F or W. Okay. So F is equal to Rn cos alpha and minus small f Rn sin alpha. Rn sin alpha acting downwards, that is why it is minus. Right? So equation number 2. So now next, dividing equation 1 by equation number 2. So what you will get? So P divided by F is equal to F Rn cos alpha plus Rn sin alpha divided by Rn cos alpha minus F Rn sin alpha. Okay. Now I shall simplify this further. So if I take Rn outside, so see how I will write now. So P is equal to this F into the bracket small f cos alpha plus sin alpha divided by cos alpha minus f sin alpha. Because Rn term, if you take outside, Rn will get cancelled. Okay. So now what I will do? Now I will take cos alpha common. Okay. So Further, let me write on this side. So what this equation will become, P is equal to F cos alpha divided by cos alpha into the bracket coefficient of friction F plus sin alpha divided by cos alpha 1 minus F sin alpha divided by cos alpha, right? So further, if I simplify, so P is equal to F cos will get cancelled, so what will remain? F plus tan alpha divided by 1 minus small f tan alpha. Okay, but what is coefficient of friction? Coefficient of friction small f, which is equal to tan phi. We have seen this yesterday's class in symbols, right? So let me remove this section. So again, the further equation will become like this. P is equal to, from here on we are continuing here, tan of phi plus tan alpha divided by 1 minus tan phi and tan alpha. Tan A plus B, that is the form. So P is equal to F into tan of A plus B. So phi plus alpha. So let us write this as equation number 3. Okay. Now students, what is torque? Torque is force into perpendicular distance. So this is what we require now. Torque required to raise the load. So torque is equal to load. Applied force is effort P into distance. So here distance, what you are taking, it is radius only, but mean radius. So with radius we can write diameter by 2. So mean diameter divided by 2. So in bracket I'll write, because torque is equal to load into distance r. You just remember this. Okay. So further, T is equal to P dm by 2 is there. So P you have already got F tan of phi plus alpha divided by 2 multiplied by dm. So torque is equal to F dm by 2 tan of phi plus alpha. So this is the expression, torque required to lift the load in a square threaded screw, which is there in data handbook, page number 111, equation 9.18a. So this derivation is very, very important. So let me show you in data handbook. So equation, you see here, page number 111, equation 9.18a. So this is the expression what you have derived. Okay, torque required to raise the load. So similarly, you can also, you are supposed to derive torque required to lower the load. Okay, so these are the things, and this free diagram is the case where you are lifting the load. Okay, when you are lowering the load, so slight difference will be there, so that we will see.